Chapter 2, as the title suggests, deals with organizing numbers into tables and graphs. And the way it's done has some precedent to it, almost like accounting principles. If you've ever taken an accounting course, and many of you may have not taken one, they speak a different language. They talk in terms of debits and credits. You never subtract anything. You always add a debit or a credit. And by the same token, APA, the American Psychological Association, has its own, I guess you could say, standards or sensibilities, might be the way to phrase it, with respect to listing data. So as I look at this table data here, the point is to take this loose array of 20 numbers and place them in a way that could be interpreted easily by someone for their consumption. So for instance, as you look at this, you see, well, maybe I had 20 people took a quiz and the lowest score was 0 and the highest score was 10. It appears to be the case that the overwhelming majority of people did pretty well on the quiz. I see a lot of 7s, 8s, 9s, and 10s, a couple 6s, and 1 4. Now, if I just listed the data horizontally as it is above, it's just not too consumable. I can get a gist from it, but it's not as helpful as I might like it to be. The better way to do that, of course, would be to list it vertically in a frequency distribution. And you can see all it means is I have 2 10s, 5 9s, 7 8s, 3 7s, 2 6s. There were no 5s, and I had a 4. Now, even though there were no 5s, APA style would have us list a 0 for that number as a placeholder, of course. Another sensibility that APA has is to make sure the numbers are listed in descending fashion, 10 through 4, or however many numbers that there were. You'll notice that the sum of the frequencies equals the number of quizzes or survey responses or what have you. So if I added 2 plus 5 plus 7 plus 3 plus 2 plus 0 plus 1, it comes up to 20. And it's very digestible in this way. Someone could look at this at a glance and say, well, if the top scores 9 or 10 were an A, did a large proportion get an A? Well, yeah, 7 out of 20, which is pretty big. It's 35%. And conversely, if an A or a B was 8, 9, or 10, you can see that now we're at 14 out of 20 did very well, a B or an A. So that suggests that whatever this wasn't patently difficult. Another thing we might do is list a proportion column. Here's another example that might deal with quizzes, let's say, or a satisfaction survey. Let's say it was a satisfaction survey. How was your experience at Jiffy Lube? And I had 10 people fill out the survey, and the highest response was a 5, and the lowest response was a 1. And you can see one person gave a 5, 2 gave a 4, 3 gave a 3, 3 gave a 2, and 1 gave a 1, for a total of 10 responses. So the proportion column can tell me something interesting. What proportion gave that answer? And of course, 1 out of 10 is 0.10, 2 out of 10, 0.20 rather, 3 out of 10, 0.30, etc. Of course, the sum of those proportions would equal 1. And of course, if I could just check that in my head, 0.1 plus 0.2 plus 0.3, etc., all equals 1. And of course, if I wanted to, I can convert those proportions to percentages, 10%, 20%, 30%, etc., for what it's worth. Now, someone could come along and say, hey, what percentage of people were either at a 4 or a 5, let's say, satisfied or very satisfied? So, well, I would just add the 0.20 plus the 0.10, or the 20% plus the 10%. And I could answer reflexively then that 30% were very satisfied. And I might be somewhat concerned that 40% conversely answered a 2 or a 1, that they were either, let's say, unsatisfied or very unsatisfied. Of course, I just made Jiffy Lube up. I have very good experiences there. But if I were running a business and I had a survey like this, I might be a little concerned because the numbers aren't super high. Now, what do we do if numbers are so diverse that having an individual frequency distribution might defeat the purpose, if you will? What if there are too many numbers? In that case, we'll offer a grouped frequency distribution. And a grouped frequency distribution places numbers in broad categories, such as 90 through 94, 85 to 89, etc. If I were to list these numbers individually, it would defeat the purpose. As I'm looking at it, I think the highest score is 94 and the lowest score is 53. If I were to list 94 down through 53 individually, that would be, my gosh, what is that? 42 numbers inclusive. And that's too many to list. So we're compelled to make a group frequency distribution. And I'll come back to that here in the next clip.